Hi, this is a high-level presentation covering Tivoli Storage Manager's deduplication features as of Tivoli Storage Manager 7.1.1. When we talk about deduplication, we're actually talking about data reduction. And Tivoli Storage Manager has always had a lot of great data reduction technologies built in. From the very beginning, Tivoli Storage Manager has offered incremental forever backup, which provides the ability just to back up new or changed files. And since Tivoli Storage Manager does not need weekly full backups, that means we save a lot of network bandwidth, as well as data storage space on the TSM server, as well as metadata information that has to be stored in the TSM database. So that in itself is a data reduction technique. We also support things like client compression, where the client can compress the files before it sends it to the TSM server, thus reducing the size of the file, the amount of network bandwidth that's needed, and the amount of storage space that is needed on the TSM server. We also offer device compression. When we migrate out to things like tape drives, we're able to utilize their device compression, as well as appliance deduplication like NAS or VTL devices that might be part of our storage pools. We do have a subfile backup capability where we can just send a portion of the file. What I'm going to concentrate on in this presentation is our TSM server-side deduplication and our TSM client-side deduplication. So we'll be going over what these are, how they work, and how they ultimately reduce the amount of data that's being stored on the TSM server. When we look at data reduction methodologies, there's a lot of different metrics we can look at to see which type of data reduction technique we should be using, or which combination of data reduction techniques we should be using. So we can see here, for instance, with client compression and incremental forever or subfile backups, that all of these are going to go out and have savings on the TSM server. But none of those provide the ability to avoid storing identical files or renamed files, or the ability to remove redundant data from the storage pools. Those pieces would be part of the TSM server-side deduplication or the TSM client-side deduplication. Some of these advantages of deduplication have to do with reducing the amount of storage that's required on the TSM server, the ability to store more data in the same amount of space because you're reducing redundant blocks, the ability to restore data from disk because we're storing this deduplicated data out on disk instead of having to pull it off of tape, the ability to save network bandwidth when we do things like client-side dedupe because we're sending less information across the network to the TSM server. And all of this means lower storage management because you're storing less data, and therefore you're saving money due to reduced energy cost as well as reduced storage environment needs. Now, some of the potential trade-offs for utilizing dedupe have to do with the amount of CPU and I/O that's required to actually go out, take the file, break it into blocks, compare those blocks with existing blocks, determine if there's a match, and then, if needed, go through and clean up the space and get rid of the redundant blocks. Also, if you're currently using encryption in your environment, deduplication does not work effectively with encryption, and that might be a consideration on whether deduplication is the right solution in your environment. Another possible issue is that when we get rid of redundant data and many files are sharing the same blocks, if you lose a piece of storage hardware, if it goes bad, you potentially lose a lot of files associated with the data that was on that segment of the lost disk. At this point, you really have to make sure you are doing backups of your storage pools so that if there is a hardware failure, you're able to recover from those. And then if you're a company that uses a lot of tape, dedupe might not work for you because you do not want to be deduping data and writing it out to tape. In fact, Tivoli Storage Manager does not even support writing deduplicated data out to tape because of the way that that would be fragmented across the linear tape and the amount of time that would take to do a restore of the data from that tape had it been deduped. One of the things you'll hear a lot about when people talk about deduplication is the deduplication ratios. And this is basically an indication of the reduction achieved by deduplication. So for instance, if you started out with 500 terabytes and after deduping it you reduced it down to 100 terabytes, you would have a ratio of 5 to 1. The problem with ratios is that there's a lot of factors that go into how these numbers are achieved. So actual ratios are highly dependent upon things like the number of sources that are providing data, the type of data that's being backed up. Is it database data that might have a lot of dead space in it? Or is it a whole bunch of files that are the same across all the different operating systems on the machines that you're backing up? The ratio might depend on the backup methodology. Are you using an incremental forever, which already reduces redundancy? Or are you using weekly full backup, which introduces a lot more redundancy? The ratio might also have to do with whether encryption or compression is being used during deduplication and how that might impact the number of matches that are found. So what you'll find when you talk to different vendors is they'll claim dedupe rates everywhere from 2 to 1 to 500 to 1. The only valid ratio is actually what you see in your shop when you're doing the deduplication, because it's your data, it's your backup methodology. Let's go ahead and take a look specifically at Tivoli Storage Manager server-side deduplication. We've seen everywhere up to a 40% increase in the amount of data that we can store in the same amount of space when you utilize deduplication on the TSM server. Now, TSM server dedupe was introduced in TSM 6.1. It works with all types of client data that's sent to it, everywhere from backup data to API data to space management data to archives to data that was already out in the storage pools, and those storage pools have now been converted to dedupe pools. Deduplication is built into Tivoli Storage Manager. It is not an add-on solution. There are no additional charges for it. It's part of our TSM Server 6.1 and above code. It does not require any specific hardware. All you need to do is take one of your existing TSM Server disk storage pools and make sure it's a device class of file, and then update that storage pool to support dedupe. It is a out-of-band process, meaning that deduplication occurs after the backup is finished. So all of the clients will back up their data to this storage pool, and then a deduplication process will kick off, which will go through, hash out the data, find the matches, and reclamation is run on that storage pool. We then free up the space and get rid of the redundant blocks of data. Here's a basic overview of the deduplication process. You see we have the client 1, 2, and 3. These TSM clients are backing up various files to the TSM server. It's backing up to a specific dedupe storage pool which has device class of file and which has deduplication turned on. After the backup is complete, we then take these files and we break them into smaller blocks, and we compare all of these blocks against existing blocks that we know, and if there's a match, then we can get rid of a redundant block. If there's not a match, then we introduce a new block into our hashing table. After we've gone through and done this deduplication, reclamation would then run and clean up the redundant blocks of data from that storage pool. When you look at implementing TSM server-side deduplication, some things you want to consider is that you're now going to be able to have lots more data being stored on disk because we're getting rid of the redundant chunks of data. You should keep data on disk for a long time. You don't want to be migrating it immediately out to tape, because when we migrate to tape or to a non-dedupe storage pool, we have to reconstitute the data prior to writing it out to tape or other non-dedupe storage pools. If you've got a lot of clients that have the same operating system backing up to the TSM server, you'll probably have a lot of matches, especially if you're backing up some of the operating system files. And when we do utilize deduplication, there is going to be a hit on the TSM server CPU and the disk I/O resources. You'll want to make sure that your TSM server has enough processing capability to perform the deduplication. You'll also need additional TSM database space because we'll be tracking these individual blocks, and a little bit more log space as well. You might consider not using server-side deduplication for specific files if those files are mission critical, because there is a little bit of overhead when we have to reconstitute those files before we can restore them. If there's no room at all for any slight delay in the restore speeds, you would not want to utilize deduplication. Likewise, if your TSM server did not have sufficient resources, or if you're migrating that data out to tape after just a few days or few hours, you would not want to use deduplication. Now, once data has been deduplicated, when we go to do things like copy it to other storage pools, maybe for copy storage pool, or if we want to replicate it out to another TSM server, there will be some considerations on how we copy or replicate that data. If the original storage pool is set up for deduplication and the copy pool or the replication pool is also set up for deduplication, then we'll just replicate or copy the new pieces over, any of the blocks that are not in the copy or replication storage pool. If the copy pool is not set up for deduplication, then we will reconstitute the files and either copy them over or replicate them over to the non-deduplicated pool. If both the source and the target are not set up for deduplication, then obviously we just proceed as normal. But if the source does not support deduplication but the target does, then deduplication will occur after it arrives at the target pool. So some of the externals that were changed to support deduplication include the define or update storage pool command. We now have a deduplicate equals no or yes option. Also, once you have the information in that storage pool, we have a dedupe requires backup that you can set to yes or no. And this indicates whether the volume in the primary dedupe can be reclaimed prior to having the copy storage pool run against it. Query occupancy now shows the reporting occupancy in the logical occupancy field. And this occupancy represents how much space this data would occupy if it wasn't in a data dedupe pool. The query process will identify data deduplication processes that are occurring. And the query storage pool will also show if deduplicate data is turned on and the amount of savings that has been earned on this storage pool. So what we just talked about was server side. Let's go ahead and take a look at client side dedupe. So client-side dedupe has the benefit of reducing the amount of network traffic when the client sends its files over to the TSM server. The client-side dedupe will actually do the deduplication on the client prior to sending it to the TSM server. And the way that it does this is it will have the ability to keep a local cache of the hash table, so it can look up and see which chunks already exist in the TSM server hash tables and which chunks are unique and need to be sent across the network to the TSM server. So here we have a demonstration of this. You can see we've got the file. It's being chunked up into specific chunks. We then compare that with the local cache to see if there's any matches. It takes the unique portions of that file and send it across to the TSM server, while it also updates the local cache as well as the TSM server's hash tables with these new matches. Then that new chunk of data is stored in the TSM server's deduplication storage pool. So the TSM server does have to have dedupe turned on the server side in order for client-side dedupe to work. When that file is migrated from the TSM server storage pool out to, for instance, tape or another non-dedupe storage pool, then the TSM server itself will reconstitute the file and write it out to the next location. So the client side does support a source side type of deduplication. It is in band, meaning that there's no post-processing required after the data is stored on the TSM server dedupe pool. It is compatible with the TSM server side dedupe. It is optimized by having this local cache store the most recent hash table so that you don't constantly have to be communicating with the TSM server to identify a dedupe match. If you only want some of the files on your client to be deduped, that's fine. You can use an include-exclude list to control which files are deduped. And we are compatible with client compression. Your TSM server and your TSM client have to at least be at version 6.2 or above. The TSM server first must enable the clients to do dedupe, and then the client itself must set up to do the deduplication as well. including if they want adding an include-exclude list to specify which files are deduped. If the file is smaller than 2 kilobytes, it will not be deduped. It won't even be candidate. Some of the restrictions on the TSM clients, other than the 2 kilobyte size limit, is it is not supported for LAN-free, for Unix HSM, for subfile backup, for API buffer copy eliminations, or for simultaneous storage pool writes. We also don't support client-side encryption, but we do allow for SSL encryption between the TSM server and client. The reason we don't allow for deduplication and encryption is shown in this example here. As you can see, we have 3 computers, each with the same file, and the file inside says important text. Well, if the first machine does not encrypt it, then we send it as important text. But if the second and third machine encrypt it using a different key, those copies turn out to look completely different from the original copy. So when we were to compare these 3 copies of the file that used to be the same, they're now completely different, and there's no deduplication benefit. We do allow compression, however. The client files are basically chunked up into data. We look and find the chunks that are unique. Then we will go ahead and compress those unique chunks and send them across the network at that point to the TSM server. So the controls that are in place for the client-side dedupe, first of all, on the server side, you have the deduplication equals either server only or client or server. If the deduplication is set to client or server, then on the client side, the client can choose either to have deduplication turned to yes, or they can turn it off to no. They can then enable a cache if they choose, if they want to have the local hash stored locally in the cache. Then you would add a dedupe cache path as well as the maximum size of that dedupe cache. Obviously, you also have to have the destination storage pool for the clients be one of the TSM server deduped pools. This is an example of the include-exclude list for the client-side dedupe. You can see we have an include.dedupe or an exclude.dedupe option. You can also utilize the client-side preference editor through the GUI if you want to be walked through a wizard to set up this deduplication options. This is an example of a reporting on the client side showing how much deduplication was achieved during the backup. Here we had 100% achieved. And this is an example utilizing the GUI, also showing the amount of data deduplication reduction that was achieved, in this case 37%. So some of the considerations when utilizing client-side dedupe is that you will need a separate session for the chunk lookup on the server. Be anticipating 1 extra session per TSM client. This means you might need to increase your max session parameter on the server. Also, if anything happens on the TSM client that would impact the cache that contains the hash tables, that hash table might have to be rebuilt from scratch in order to be back in sync with the TSM server. One other consideration, if you're using multiple processes to do the backup, only one process can be utilizing the hash table that's stored in the local cache. The other processes will have to connect directly with the TSM server and get its hash information from the server itself. If you are implementing deduplication, here's a checklist that I took directly from our online support. First of all, you want to determine the impact it'll have on your TSM database capacity as well as on the logs, just to make sure that you have sized your database and logs accurately for deduplication. You'll want to sit down and figure out which client nodes you want to utilize deduplication, and then if you want them to utilize only server-side deduplication, or if you want them also to have the option of doing client-side deduplication. If you do choose client-side deduplication, you'll want to determine if you want to utilize SSL for the transfer of data between the client and server. Then you want to look at the storage pools itself and either choose an existing sequential access disk file storage pool or create a new one and then turn on data deduplication for that specific storage pool. The next thing you'll need to look at is how you're going to control the duplicate identification process. If you want to either have that as a scheduled process that runs automatically all the time, or if you want to be starting and stopping that manually, or if you want to be able to start it and then perhaps interrupt it to change the number of processes that are running against that. So what we talked about today was TSM data reduction techniques. Tivoli Storage Manager has always offered incremental forever, and this only backs up new or changed files. We've also always had client compression and the ability to also use device and application deduplication and compression. We introduced in version 6.1 was the TSM server-side deduplication, and then in TSM 6.2 we introduced TSM client-side deduplication. Both the server and client-side deduplication are part of everyday TSM code. You don't need to purchase any extra options, and they do allow the ability to drastically reduce the amount of data that's being stored in the TSM disk storage pools and the amount of data that has to be sent across the network from the TSM clients. So thank you for your time today. Also, we have some other actual demos of deduplication being set up on the TSM server and client, so take a look at those too. Thanks again.